Plain OS files are simple to use but scale poorly under pressure. While database engines maintain sub-millisecond lookups under high concurrency, raw file systems suffer severe degradation due to I/O bottlenecks, lock contention, and a total lack of built-in security layers. When two users edit a single file simultaneously, they risk silent, destructive overwrites. Databases elegantly solve this conflict using robust concurrency controllers. By actively managing transaction queues and applying precise row-level locks, database engines safely scale concurrent operations from a few isolated users to tens of thousands of simultaneous requests without data loss. During a critical financial transfer, an unexpected midway system crash or power outage will easily corrupt simple file systems. In contrast, database engines enforce strict atomicity and consistency. By utilizing write-ahead logging and double-write buffers, they guarantee that every single transaction either commits completely to disk or safely rolls back to its original state. While basic file systems offer only coarse, binary OS permissions and easily collapse under heavy transactional loads, databases deliver fine-grained row and column security alongside sustained, sub-millisecond query performance. When it comes to building and scaling robust, reliable applications, a managed database serves as the irreplaceable backbone of modern software infrastructure.